Well, hey folks, to keep the party going, we've got Neil Weitzel, and he's the SOC manager over at Thredex. Neil's got 15 years of experience in roles from user support to leading security programs. He's got expertise in security architecture, cybersecurity best practices, and what do you know? He's an active member of the security community. He has delivered presentations at DEF CON, OWASP, local security meetups, you name it. He's also, what do you know, an adjunct lecturer on software engineering at Indiana University. Neil, take it away, man.
Hey, thanks, Jake. Yep, as Jake said, I'm Neil Weitzel. I have a ton of experience attacking, protecting, architecting web applications, APIs, and kind of various web technologies. I also build teams and programs kind of around those endeavors, but currently I am the manager of the Security Operations Center here at Thredex. So kind of give you guys a little idea of what Thredex is here. So kind of level set here so you guys can kind of understand how Thredex is able to view Log4j. There's a lot of different perspectives on this, whether you're a developer kind of, fixing code, or whether you're, an attacker or kind of exploit it. So we kind of sit in between those two areas here at Thredex. In short, we're a web application and API firewall technology and service. So essentially we analyze HTTP traffic between users and applications, or systems and API endpoints. And behind our technology is our service, the Security Operations Center, where is kind of mainly where I sit. And we provide 24/7 security experts that analyze the threats of that HTTP traffic, thwart attacks. And we do that using our reverse proxy technology here at Thredex. We're able to do this pretty well with a special blend and combination of building collaborative relationships with our clients. So we kind of need to know what we're protecting, what are the areas of interest for them, kind of what the technology is that their applications are built on, things of that nature. Our advanced understanding of attacks, mitigation techniques, using threat feeds, and kind of using those in a special kind of special way of leveraging our technology platform, which kind of puts us with a lot of information that's like actionable right at our fingertips. So let's kind of look at that, how we would see that using the technology. So what does that really mean for us? Simply, our application or our platform is able to aggregate risk based on kind of behavioral analysis. When we see something nefarious or anomalous, we give it a risk score. And it's really based on a variety of things, such as where we observed that particular traffic, where it might sit on the kill chain. You might think that like a smaller risk score might be assigned to like reconnaissance or information gathering activity, whereas a higher risk score would be assigned to known bad payloads or special characters reserved for commands or markup languages. Similarly, we checked like the intensity, the frequency, location, and complexity of the attack or match against our rule sets. And this is all kind of done in the background of our reverse proxy and something we call hacker mind, which is essentially the brain or oracle of our platform. And it assigns these risk scores or increases it appropriately if we've seen like that entity before performing bad or nefarious anomalous activity. So essentially, we give HTTP traffic, kind of round that up here, a risk score and increase it by identifying the paths the attacker is taking. Once an entity reaches a threshold of a 70 risk score, we block that entity for a period of time. If that happens 3 times, we say, hey, no more. We put them on a block list indefinitely. This method is really great for human errors that happen sometimes and are oftentimes kind of triggered as false positives and other platforms or other technologies. So, if a user like logs in, multiple times with a failed, credentials that sometimes get picked up as a brute force or a credential stuffing attack, things of that nature, we're really good at identifying those versus, just blocking those entities. Of course, we can also block, individual requests immediately if, for example, they contain like a known malicious payload. In general, our platform is able to do this pretty well because we have, 24/7 people, feeding it information, threat feeds, writing rules, things of that nature. That kind of lets you know a little bit about where, our technology sits and kind of how our team's able to do it. So now let's kind of like look at that actually in the Log4j context here. So as soon as, the Log4j 0-day vulnerability began, we essentially jumped right into action. And this has really helped us, stay ahead of the attack and get ahead of the attack right at the onset. on that shift, when that happened, we essentially divided our on-shift resources into two teams. The first team was, hey, you go off and understand how this attack works. So they uncovered pretty much exactly how this vulnerability works, and kind of the highlights there. For those who haven't dove into the Log4j vulnerability, essentially within Java applications, a lot of them leverage Log4j as a logging mechanism. And when you're logging things, there's oftentimes like, hey, this user performed this action. And we want to look those up from external entities like LDAP, for an instance. And so when we do that, we can use things like J and DI lookup with LDAP to pull in those entities, maybe like the username, a GUID that references that particular user or entity or system or machine, so we can understand what actually is happening in the logs. Because those are reaching out, that's an external call. And so that team was able to immediately identify like, oh, hey, this is exactly how this attack is going to reach out and how somebody might use it to get like reverse shell on a system. So that was kind of like what team one did. The second team really began to analyze the attacks that we were already seeing using kind of our current rule sets, understanding that, hey, we're getting hits on particular entities here and here. What do those payloads look like? Understanding what those matches are in our platform. And then they started to look at those a little deeper and analyze each one of the HTTP calls that might have a Log4j payload in it, comparing that with threat feeds. And so we started performing testing using a lot of that information. And that testing was done really quickly to kind of determine if there's any gaps in our current rule sets or out of the box rule sets, and how our risk aggregator works. And so using those kind of two teams approach, we quickly determined like together that our general common rules could catch some of the Log4j payloads, but not everything. And it may or may not increase the risk scores quickly enough to block attackers that were at that point in time were kind of performing reconnaissance or identifying systems that could be vulnerable to Log4j 0 day. So using that technique, we started to enhance our rule sets and deploy that to all of our customers, so we kind of can deploy all at once to kind of close those gaps. Then we began validating those rules by testing them, using our understanding of the attack, known attack vectors, obviously kind of reading threat feeds more and more and more, and using data directly from our clients. And that's kind of one of the huge, internal threat feeds we have. And it's a huge benefit for us that, we have a huge subset or large quantities of traffic that we can analyze. And with, a large sample size, that really means if, one anomaly on one customer on one site, we see something, we can actually kind of like use that to propagate or cross-pollinate that rule or those payloads or those protections across all of our clients. So that's one way where if we see like a payload in one area, we can go ahead and spread that across. And so that really kind of helped us stay ahead of evolving attacks that maybe we're targeting particular entities. So one thing that we observed, much like any injection style attack, especially over HTTP protocol, was a variety of obfuscation and encoding techniques attempting to bypass, our platform or WAFs in general. As most of you know, security is a bit of an arms race, or an escalation of attack sophistication versus maturity of security layers. So as Log4j started, it was mainly pretty obvious payloads in some pretty notorious locations, used by a ton of attacks or script kiddies, things of that nature. And they are mostly in HTTP headers or in a variety of locations within the head of an HTTP request. Of course, we saw this, these payloads and some of these simple attacks in HTTP request bodies too. But in general, these were fairly easy to catch, block, match against, and most platforms and WAFs and security analysts can kind of do this pretty well. Then kind of came the next level, right? The next level of attackers really tried to encode their payloads using techniques like you can kind of see here in the second line, using like URL or base64 encoding. And so they're trying to kind of obfuscate or see if, some pattern matching was just looking for, particular entities, that was stopping this. And this is where, technology platforms start to begin to struggle with handling encoding techniques or decoding payloads and then trying to evaluate them. It requires some additional decision-making, coding, and processing power by the technology. So fortunately for our SOC here at Thredex, our platform is insanely efficient at this. It'll kind of decode ad nauseum until we get back to a plain text payload for evaluation against our rule sets. This is really possible because of some slim, efficient technology choices our engineers made and some magic programming through Rust. But what that really means is our analysts are able to focus on the payloads themselves and the attack vectors versus going through every permutation of encoding and obfuscation technique that an attacker might use. And that's why, to a small extent, some security analysts begin to create unforeseen gaps when you're at this level of the encoding is used. And this is just due to the rule logic necessary to match against all these encoding and obfuscation types. So then at the bottom here, you can see in the last snippet, Log4j payloads that leverage the entire Java language. Since J and DI is evaluated in Java, some of the more complex payloads actually leverage the language itself to piece together payloads during execution. This is where both a lot of security technology and security experts struggle to mitigate these payloads. Security analysts struggle because they frequently need to write complex regular expressions at this point to find these payloads. And when you include encodings, it's rather difficult to write multiple regular expressions for each of the encoding types that leverage an entire programming language. Also, the technology begins to struggle here because regular expressions are just insanely expensive in terms of computational resources. So oftentimes regular expression rules introduce latency, and that, with complex regular expression rules to begin with that need to be written, they're really hard to get perfect or correct. And so those two things combined, that often introduces a lot of gaps. So this is kind of how this started to appear in our platform. So you can see as we wrote these rules and we were able to kind of stay up with the attack, we could see this just right ahead in our dashboard. This is pretty much just kind of a screenshot of what that looks like from our SOC standpoint or our customer standpoint. So ideally, this arms race that we're talking about, where the attackers are getting more sophisticated in attacks, and we're trying to write better rules or mitigate the attacks. The ideal end of this arms race or escalation ends with a full remediation of the vulnerabilities and the mitigation of the threats. To do this, we have to continue to stay ahead of the attack by tracking techniques the attackers are using. So we analyze matches with our rules for evolving payloads and sophisticated attacks, constantly check the threat feeds, collaborate with other security researchers, and constantly examine if there's anything that we haven't seen or considered in our rules and testing. And then we loop that back and we kind of create this feedback loop where we continue the testing of those things. We will create a feedback loop by testing and attacking our own sandbox environments, and we'll use that data to enhance our understanding of the attack, supply that knowledge, lather, rinse, repeat, go through that again. Our goal now is really to buy time for application and systems to implement the correct patches and fixes. We understand that we are a single layer of protection, in terms of security, but really not the final layer. So with collaboration from our clients, we understand, their upgrade path and what they're doing to fix their vulnerable systems, when they occur. Some people just didn't have Log4j, but they were just getting hit with it either way. So specifically in Log4j, that means patching to the most up-to-date version, or just removing the J and DI, class altogether. So this kind of helps us get to that final layer of a non-vulnerable system, one that's patched or remove the vulnerable code. And without that, there's not really a 100% sure way to fix these types of situations. So for that reason, be pretty wary of anybody in the WAF or API industry that says they can 100% protect you. Unfortunately, that's just not how this technology works. Security is definitely not a set it and forget it game. You need to ensure that you have experts constantly analyzing and tuning your security systems, or providing that time or layer of security for you to implement the correct patches and fixes. So what were our lessons learned as we look back after 60 days and beyond? Simply put, our swift and focused efforts early on, right as Log4j 0 day was released, has really helped us provide a solid layer of security to our clients in their applications. By really thinking like an attacker, creating that data feedback loop, and driving enhancements to rules and security actions, we've really we've stopped, and thwarted quite a few would-be attackers. During this exercise, we learned that our relationships with our customers is easily one of the most valuable information sources we have. In a SOC, you don't always know every piece of technology of an application or system that you're assigned to protect, like perhaps Log4J, right? So being able to work with customers, ask them questions about their technology, find out if they are leveraging external lookups like JNDI, helped us know where we needed to get surgical or clever with our rules. It really showed us, that the collaboration with stakeholders, developers, network admins, system admins, security professionals, management, et cetera, it's really paramount to a successful security strategy. So, today, many of the attackers are attempting, more targeted attacks and leveraging other protocols. Early on, we saw some of the early, like LDAP within JNDI lookup. Now we're seeing a little bit more ROII and RMI calls mixed with those payloads. And this is likely going to continue as attackers try different external lookup protocols, encodings, obfuscation techniques. So when this 0 day was first announced, many attackers started profiling systems to see, who was vulnerable, what calls back they got. And it's really hard for us to evaluate right now how successful they were. And so, however, using that recon data, they're likely going to cross-correlate that with, other external references. Perhaps a user was asking questions about, on a public forum, hey, is our system we use this vulnerable? And if they use that, username handle elsewhere, or maybe they use their work domain, things of that nature, that can be cross-correlated with, some of the initial recon data. And some of that might be able to identify systems that people are responsible for with that, original recon data. And attackers will likely create sophisticated, and clever payloads that will target those specific systems or organizations in the future if they think they might be vulnerable or they think they might be, lucrative to them. So there are a few best practices that'll really help prepare you, or at least provide some level of confidence for a 0 day threat, right? So the biggest things are, understand the technologies that you use, profile and inventory them, know what you have, know who uses it and how you use it, and understand what version of it you use and why you made the decisions you did. Really the next step there is kind of after you've profiled them, understand, how you update them, keep your software and technology up to date, implement a religious practice of patching software. Doing this now, it'll save you so many headaches later. Even though like the nature of a 0 day is there's not a known fix right now, if you're not up to date, it's easier to patch from, version 4 to 5 than it is from, 1 to 5. So, make sure that you kind of have that already built into your, ecosystem environment, your regular practices. Read the release notes when there is a change or there is an update, and understand why the patch was issued and any threat intel around that technology. If there is a security vulnerability, did you use that technology in a way that it was vulnerable, like to the security fix that was released in the patch? Can you check if you had any attacks or bad actors attempting to exploit that vulnerability? Do you know who you would ask or where you would check for that type of information? So this also means like understanding the sources and sinks of your applications. Know what information goes all the way into your application, what information is supplied to it, and what business operations operate on it, and what things come out of it. Really understand your sources and sinks and what that is supposed to look like, what your intended operations are. In general, everybody wants to protect their technology and applications, but to do so, you need to understand what technology you have, how it works, and who is working on it to secure that technology. Cool. Thank you for listening to the talk. If you're looking for additional information, hit us up in the SANS Slack channel, or check out our website at thredex.com.
Okay, well now I'd be remiss. We've got some time here, right? So I'd be remiss not to have some discussion here. We've got a couple of you guys got a couple of questions here, although I'm not sure that they're 100% specific to what you do over at Thredex. If you want to tackle either of those, happy to do that. Otherwise, I'm happy to have a discussion here and get a little bit more into the audience, or a little bit more with the audience. Tell me a little bit more about, like, as far as what Thredex does, in case we missed forest for the trees here. What do your clients typically come on with Thredex for?
Providing like a layer of protection, HTTP, protection for their web applications, our APIs. That's mostly, we also can do pretty much anything a reverse proxy can do. We can kind of do some customized things there, but we're pretty efficient in being able to look at things in transit between users, attackers, would-be attackers, and application stacks. And a lot of times we'll either sit before an application or maybe a load balancer, things like that, and we can kind of look at things right in transit.
Yeah. So folks, I do a lot of incident response, and I'll tell you that as we kick this off, I heard the term SOC. And I got to tell you, Neil, man, I died just a little bit inside, right? Because so many people think SOC and they think like event log, endpoint event log, right? and well, no, I don't mean this as a knock, right?
Right. No.
Clarify for the audience too, right? Because so many security ops centers, right? You say, okay, cool. Do you have the web service logs? And the answer usually is start confusion / maybe we have some, but then you ask the follow-on question of how do you analyze those? And they're like, we look for bad. And I'm like, what does bad look like?
How do you do that threat intelligence? How do you look into those things?
Yeah. You iterate through that and you find out that the majority of security ops centers out there don't have any handle on, web services. And then if they do, and then you ask the meta question of, does your organization expose any APIs, like for a mobile app? And that's when stark panic kicks in.
Yeah.
Right? You want to talk a little bit about that and onboarding customers and stuff?
Oh, absolutely. In general, we really try to profile each one of our clients or each one of our customers, because the more we understand more about their application, what is normal for them, normal operating procedures, then anything outside of that normal, we're able to say, hey, something's happening over there. The risk score that we talked about earlier, hey, this is a little weird. Let's bump it up 10, bump it up 20. Hey, this guy's doing this a bunch. Like, now let's bump it up a bunch more. And we can do some really clever things like interrogate particular entities, and being able to do that, and on an HTTP level, that can mean like implementing things in a response even. So we can kind of you might think like reCAPTCHA, inject some JavaScript here and there, see how the browser reacts, see if it's headless, things like that nature. So we're able to do some pretty clever things to ensure that who's acting or working with our clients is who we intend to actually work with them. And to kind of like, a lot of times when you say SOC, a lot of people think, oh, there's a bunch of SIEM data, there's a lot of, just kind of application logs, and it's very reactive. You're looking for an indicator of a compromise a lot of times. We kind of sit on the other side of this equation in our SOC, and we're looking for indicators of an attack versus that compromise. So we're trying to stop it before it gets there in transit, not looking at things that have already happened. Now, granted, like, for that matter, we also do analyze things after they've happened to see if there is something that we're like, oh, did that get through? Like in the case of Log4J, hey, we have some partial matches here. And so maybe we need to increase that risk score more, or maybe we need to increase the rule set a little, make it a little bit better. So, we can tweak that a little bit, run that out to all of our clients, or maybe we have one client that actually uses JNDI lookups. And so we're going to say, okay, let's get kind of surgical here. Can we narrow that down so it's only operating where you intend it to operate? Things like that.
That's a fantastic point, by the way, right? Because and there's so many places I can pivot right here, but I'd like to pivot right there on the you mentioned that if there's an intentional place, you happen to be using JNDI, then again, you've got a profile on that and have built a profile on that with your customers, and dare I say, know the app better than most of the security teams, internal security teams themselves. But
unfortunately, but yes.
Well, I mean, there's only.
But
so
they
much
rely
time
on
in
us,
the day,
so no, it's
right?
probably not unfortunate for them.
No, exactly that, right? That's why you're, it's like literally like, hey, I know what I can't do, or I know what don't have the bandwidth for, what have your talent in house, shift it out. But so often we heard the trope as Log4j kicked off, just disable GenD, right?
Yeah.
Just for, and here, you're saying, hey, no problem, right? If you use it someplace, we know where that's at.
Exactly.
And we'll allow it there, but nowhere else, right?
Yeah, we really try to, backing up a second here, to, like, when we're trying to profile applications, those are the types of things we want to know. Understand where, like, again, those sources and sinks I talked about at the end there. If we know where things are coming in and where you're making external calls, we can do a lot more to protect those things. to kind of like talk a little bit about APIs there as well, we try to think of the application a little bit, as, hey, what is its schema? Because in the API sense, we have a schema, and it's a little bit sometimes like, hey, did this fall in or out of schema? Is this exactly what we expected? But how do we do that for a web application that's very dynamic, where it's not a system talking to a system? So we try to kind of like leverage that philosophy on both sides of the HTTP protocol equation.
And this isn't all a manual process, right? You built code around this. I'm sure that assists hugely in this process, right?
Yeah, like that's kind of the nice part here. Our platform kind of puts a lot of actionable information right at the SOC's fingertips. So, we don't have to do a lot of the heavy lifting. A lot of these anomalies, behavioral things are kind of like right in our face. We can say, oh, hey, let me look at that thing. And we can act on it or kind of adjust things, tweak things really quickly for that. And yeah, that kind of helps a lot.
So one of the other things that you mentioned in the presentation, and I love that comparison, right? We were showing like, hey, here's new encodings, right? Can you speak a little bit to why that matters so much? I watch clients, obviously dealing with like, okay, I've got a rule in place, and then Wired or Vice or insert whoever here, right, run a story, and they're like, new bypass. And of course, at that level, right, it's like nobody gets typically there's not a lot of detail about like what the bypass is. You don't know whether they're reporting on an actual new bypass or reporting on somebody else's reporting about a bypass right. And so then I've got clients that are like, are we still protected? Are we not?
Yeah.
Can you speak a little bit to why that cross-sectional view that you have at ThreatX matters so much for that?
In general, I mean, so the attack sophistication is always going to increase. Kind of like what I was saying is like, especially on injection style attacks. First and foremost, hey, they want to profile exactly. Attackers typically do want to profile who's vulnerable, where can we do things, and so a lot of times these are pretty rudimentary script kiddie level, quick, easy JNDI, LDAP, to attacker server, and they're checking their attacker server. Did I get a ping back? Well, we write a rule, and that's just going to block one particular occurrence of this payload. That's just like, hey, just on JNDI, or maybe we write something that's for JNDI LDAP. So we have to kind of do two folds here, understand the actual attack itself. So how is this, where is the vulnerability sit, so that we understand what protocols, is it not just LDAP, is it also RMI, things like that, where this can actually get executed. And then, and in the injection sense, like what are people going to try to do in that attacker world to bypass what we do, right? And in our case, we're able to decode pretty much anything ad nauseum. Like our platform really does it's really efficient using Rust to, anything that we see weird, it's like, hey, can I decode this? Okay, cool. Can I decode it again and again and again? And so it'll get us right back, so we can really focus on, hey, is this Java markup, or is this like actually programmatic logic that's trying to execute something, versus all of these things that would typically bypass a lot of web application firewalls or API protections, right? Because if you're just writing one rule to catch, hey, does it have JNDI in it? All of a sudden it's like, well, but no, I'll just encode it, or I'll just concatenate string together in Java to do these things. So we can do things pretty efficiently, like looking for multiple contains versus writing very complex regular expressions. And that's kind of where the efficiency of what we have in the platform does the heavy lifting for us. Because if you do that through regular expressions, there's a lot of room for error. There's a lot of room also that it's just going to cause a lot of headache for your systems that run those regular expressions. If you're trying to traverse an entire HTTP body, or even a header for that matter, using a regular expression, looking for the occurrence of like first a J, then an I, that can be very, very cumbersome.
Yeah, no, definitely. And that's been a common issue, right, with WAF over time. One other thing that you mentioned here that I fear some of the audience probably doesn't know really what you meant. Can you describe, you mentioned trying to determine is somebody in a headless browser or
Sure.
something else, like why is that significant?
So when you visit a website just using Firefox or Chrome or whatever flavor of the month you're using these days, a lot of times there's things like a user agent or a lot of headers that get put in place. Probably every plugin that you've installed includes an extra header when you visit a website, right? And so that sends over an HTTP request, and when it reaches the application server, it sees the entire list of headers, and it's able to evaluate those for particular things. Maybe if it says like, oh, this person's using Microsoft Edge, so I'm going to send the website this way, as opposed to if it's a different web engine, like maybe in like Mozilla, okay, we're going to send it this way. So we're able to send a little bit different based off of those headers. Now, in the case of like a headless browser, a lot of those headers or information just isn't present. There are a lot of things that it just looks like a raw HTTP request, and we look for those things in terms of the anomalies where likely somebody's not trying to visit a fully dynamic, complex web 2.0 application using a headless browser, just trying to look at the raw HTTP requests and responses. So in those cases, like, well, what's going on here? Is somebody removing those using their browser, and why? Or is it somebody who's just doing like a curl command? And a curl command might just like specifically send that HTTP request raw, and you can think like just plain text and ask for the response back into the terminal.
Yeah. And that's fantastic, because there are so many attacks, and we've talked, in other SANS presentations, we've talked about this in the past, but, there's the old curl wget, whatever, and then there's is the browser processing JavaScript, right? Because curl isn't, right? But is a browser and then you've got the follow-up of, is the browser being scripted by a threat actor, right?
Yes.
Using a Selenium or some other automation functionality, right? So, yeah. So the ability to detect all that, of course, is important in what Thredex does, right?
That's our sweet spot.
Winning. Well, hey, Neil, thank you so much for joining us today, man. This has been fantastic, and I appreciate you and Thredex bringing this content to the SANS community. If you've got other questions for Neil, he'll be over in the Thredex chat. But Neil, thank you so much, man. Appreciate it.
Hey, thanks, guys. Happy Friday to everyone.